Hello, welcome. Let's try to solve another Leetcode problem. 2832, maximum range that each element is maximum in it. So we are given a zero-indexed array nums of distinct integers, and let us define zero-indexed array answers of the same length as nums. So the answer gonna be the same length as nums. So the nums, for example, the length is 5, so the length of the answer is still 5. So answer I is the maximum length of a subarray from nums L to R, such that the maximum element in that array is equal to nums I. Yeah, so this means, for example, for this element, the maximum value is 1. So our result gonna be 1. Because 1 to the right side, the maximum element has to be 1, so it cannot extend. And for the left side, there's nothing, it cannot extend, so it is 1. So for this number 5, it can extend to the left side, it is 1, because 1, 5, the maximum gonna still be 5. And what about the right side? It can extend to 4 and 3, but it cannot extend to 6, because 6 is bigger than 5. So the length of this position gonna be 4, so the answer is 1 gonna be 4. And then for this number 4, it can extend to the left side, so the maximum length is 2, so here is 2. And for this 3, it cannot extend to the left, and it cannot extend to the right, so the maximum is 1. And for this number 6, it cannot extend to right, but it can extend to left. It can extend to all those numbers, so the result is going to be 5. So if you understand the problem, basically, yeah, you can try to solve it. I think the description makes it confusing. Answer I is the maximum length of a subarray nums L to R such that the maximum length and maximum element in that subarray is equal to nums I. Yeah, so maybe the description should be like answer I is the maximum length of a subarray from this nums L to R, and also nums I is the maximum element. Yeah. So anyway, let's try to solve the problem. So the idea is that for each of the elements, so for example, I'm gonna use 1, 5, 4, 3, and 6. Yeah. Basically, this problem can turn to find the next greater element. As you know, if we are going to find the next greater element, it's gonna be a monotonic stack problem. And it is monotonic decreasing stack. Why? Because for this number 5, we are going to find the next greater element, it is the 6. So if we can find the 6, so we can find the distance. Yeah. So for the distance, we can put it inside our result array. But from the beginning, I'm gonna define the result array for this index as 1. So the distance from 5 to 6 is gonna be this index j minus this index I minus 1. So it's gonna be 2. Because this 1 plus 2 is going to be 3. Yeah. So currently, the distance from the right side is going to be 3. And next, I want to find the distance to the left side. So for this number 5, I want to find the next greater, previous greater element. So it must be here. For example, there's going to be an infinity. I'm going to prepare it like that. Yeah. So if I didn't find it, I'm going to prepare an infinity inside the nums array. So in this case, I can always find the next greater element or the previous greater element. Yeah. So for this 5, I can find the previous greater element. It is this index. So for example, this is the index I, and this is let me just use this as the index I, and this is the index j. Yeah. So what is the distance? It is I minus j minus 1. So I is, for example, this is 2, and this is 0, 2 minus 0 minus 1. So the distance is only for this number, it is 1. So 3 plus 1. So currently for this number 5, so the distance is 4. So I can put this 4 inside the index 1. For this number 5, it is 4. Yeah. So the problem becomes how can we find the next greater element and previous greater element. So for finding the next greater element, we can use a monotonic decreasing stack, and yeah, it is monotonic decreasing. If this number is bigger than that, we're gonna record the next greater element, and we can find the distance. Yeah. So what about the previous greater element? So we can reverse this array. So we're gonna reverse it. After reverse the array, we still gonna use the same function, monotonic decreasing stack, and we're gonna find the next greater element. We just need to check the index. Before the index is I, now the index should be n minus I minus 1. We just need to change the index and put it inside of the result array. Now let's try to code it up from here. So I need a stack. It's gonna be an empty stack, and I need to prepare the nums. As I would to find the next greater element, so I would to prepare an infinity plus the nums plus the infinity. This is just to avoid checking the edge cases. This makes sure I can always find the next greater element. And I'm gonna define a variable n. It's gonna be length of the nums. Now I can start to get the next greater element. So for I x in enumerate the nums. So I can check the stack exists and my current number is more than nums stack minus 1. So basically I can pop index j out of the stack. But what I need to do, I need to put something inside my result array. So currently I can define a result array. It's gonna be from the beginning, it's gonna be 1 times n. Because finally I will return something like result 1 to minus 1. I need to delete this infinity and this infinity at both sides. Now let me check what I need to do. So currently from the beginning inside my result array I will have a 1, because definitely for each of the number at least it's gonna have a length of 1. As you can see, at least it's gonna have a length of 1, and then we're gonna expand to the right side and then to the left side. So first let's expand to the right side. So we are calculating the next greater element. Now we can record the result. So the result should be this j, because j is our popped index. So now the result j would plus a distance. So the distance would be I is bigger minus j minus 1. So this is going to be the formula. After that, so the stack gonna append the index I. Now let's just print out the result 1 to minus 1. Let's just check what is inside. Currently we're just calculating one side. Definitely it's gonna be wrong because we just calculated at one side. Let's just check. So for this number 1, it is 1, it is okay. So for this number 5 at the right side. So 5 at the right side is going to be 4, 3, so it's going to be 3 because we didn't calculate the left side. It is okay. So for this number 4 at the right side it is 2, for this 3 at the right side it is 1, and for this 6 at the right side it is 1. So it means our calculation is right because we only calculated at one side. Now we are going to calculate the left side. So for the left side we just need to prepare an empty stack. So stack would be an empty stack, and just copy the same code. We just copy this code because it's gonna be the same. But before that, we're gonna reverse the nums. So the nums should be nums reverse. So after reverse the nums, we are going to still use the monotonic decreasing stack, and we are going to check the next greater element. So we don't need to change anything about the code, and we only need to change the index. So currently this is the index j. Actually it should be n minus j minus 1. Because we reversed the array. After reverse, so the index should change. So before it, for example, the j is 0. Now what is our index? It should be n minus 0 minus 1. It should be n minus 1 because we reversed the index. So while we pop out an index, we need also to reverse it. So the calculation for the reverse is n minus j minus 1. And the calculation for the distance is going to be the same because after reverse, we didn't change the distance. Yeah, so for example, 1, 5, 5, 1, we didn't change the distance. Yeah, let me maybe try to put an example here. So after reverse, so the numbers inside it's gonna be like 6, 3, 4, 5, and 1. So while we are calculating this 5, so this is the next greater element. So the distance is just 1 because we are not calculating this 5. It's only one element, yeah, after reverse. But how did we get the result? So for example, it is monotonic. It is monotonic decreasing, and here we have an infinity, and we're gonna use this infinity to pop out this 1 and pop out this 5. Yeah, we will ignore those 3 numbers. We will only consider 1 and 5. Maybe this is going to be easier for us to analyze. Yeah, so we're going to use this infinity to pop out 1. So if we pop out 1, so what is the index? So the index is going to be n minus 1. But for the index, it should be 0. So this means n minus this n minus 1 plus 1. So it's going to be 0. So n minus 1, it means n minus n plus 1 minus 1, it's going to be 0. So it's exactly the same. Yeah. After repeat these areas, I think we can get everything right. Now let me just run it to check. As you can see, it is exactly like the result. Yeah. So let me delete the print and submit it to check the result. Yeah, as you can see, it works, and the time complexity is ON. Yeah, for the code, as you see, we repeated some of the code. You can also combine them together. It just be a little bit harder, but the idea is the same. Or you can also use this kind of while loop to check the next greater element, and use another loop. You don't need to reverse the nums. You just check the previous greater element. It is also okay. Yeah, but anyway, you can check the result. Thank you for watching. See you next time.